Hey grade 11s. I created a video for you today just so that we don't lose any class time and that we stay right on track. So today you're going to follow along in your notes and fill in the blanks as we go, just like normal. So we're going to talk about something called completing the square. And completing the square is the process of changing standard form into vertex form. Please feel free to pause the video at any time along here if you need some time catching up. So when we're talking about completing the square, really that's when we have a quadratic that's an x squared plus a bx, and we take the b value and split it into two pieces, so just like you see here, split it into two pieces, and then we have to figure out what that little end piece is that helps us actually complete the square. So that's really what we're going to be doing as we go along here, is we're going to be finding the little piece that completes the rest of the perfect square. So let's say that you have x squared plus 6x plus 9. If I use my algebra tiles to create this, I have my x squared tile right here. I've got 3 x's here, I could put 3 x's down here, and then I have 9 ones that would fit nicely into those positions. So you can see that this makes a perfect square. So x squared plus 6x plus 9 is already a perfect square. However, let's say that you have x squared plus 4x. How could you figure out what would make this a perfect square? So if I look at how I arrange my algebra tiles here, I have my x squared, I've got 2 of my x's here and 2 of my x's here. So how many ones would I need to fit into this position? And if you're thinking 4, you are correct. You would need 4 little 1 squares to fit into this position to be a perfect square. So putting a 4 in there would turn that quadratic into a perfect square quadratic. So let's look at this one. Is this a perfect square? So you should see just from how I've created my algebra tiles here that it's not a perfect square because I've got my x squared and 2 x's, but I'd only need 1 square in here to actually complete the square to make it a perfect square, not 3. So let's take a look here at the steps to complete the square. Just take a second to pause the video and read through these, and then we will continue. Alright, so for our first example, we want to rewrite it by completing the square. So my first step is that I would put my brackets around the first two terms, and then we're going to put our plus blank and our minus blank. So we'd get x squared plus 6x plus blank minus blank plus 5. Now we have to do a plus blank and a minus blank so that our equation stays balanced and so that we haven't actually added anything extra because we've actually taken it away next. So this part right here kind of evens each other out. Our next step is then that we have to put in the blanks b over 2 squared. So if I look, my b value here is 6. So I'm going to go 6 divided by 2 and square that. So in other words, 3 squared is 9. So I'm going to put a plus 9 and a minus 9 into those blanks. Alright, so the first 3 terms in this process is now actually a perfect square. So we've created a perfect square. Now all we need to do is actually factor that perfect square. And in your factor is always going to be x plus b over 2, and b over 2 in this case is 3 squared. And then at the end here we have to deal with our minus 9 and our positive 5. So minus 9 plus 5 gives us negative 4. So now we have an equation where we have vertex form. P is negative 3, Q is negative 4. So you can clearly see your vertex. Alright, we're going to try example B here, but you'll notice that in example B there's an A value. So what we should do first here is we should actually, after grouping our first two terms, we should factor that 3 out of the first two terms because that'll have an influence on it later. So if I factor the 3 out, I get x squared minus 4x, then I can put my plus blank and my minus blank. Now remember the part that goes in the blanks is going to be b, which in this case is negative 4, so b over 2 squared. So in this case b, like I said, is negative 4, so negative 4 over 2 squared gives us a value of 4. So negative 2 squared is 4. So I need to put 4 in my plus blank and minus blank. And then just like last time when we group the first three terms, that's our perfect trinomial square. So I can go ahead and continue this by factoring that perfect trinomial square to get x minus 2 squared. Again, negative 2 was what I got out of my b value here, so that would be my what goes in the brackets. Now there's one other little step here. The 3 needs to get applied back to this 4, because technically that 3 was on the outside of the brackets that whole time. So 3 times negative 4 gives me minus 12 minus 9 again. So your final answer in vertex form would be 3x minus 2 squared minus 21. Alright, so let's look at a third example then. Remember to please pause the video at any time if you feel like you need to take a second to copy or ask questions or whatnot. So this time we have an A and a B, but we have no C. So you could actually put a plus 0 at the end there if you wanted to hold the place of the C, but there is no C value. So step 1, like normal, is we group the first two terms, and then I can see here that I have an A value of negative 5, so I should factor that out. So I factor out my negative 5, and I'm left with x squared plus 14x, and I can right away put in my plus blank and my minus blank, and then I have my plus 0 at the end. So then remember, in my blanks, I'm going to go b, so 14 divided by 2 squared. So in other words, that's 7 squared, or 49. So the value of 49 is what's going to go in my blanks. Then I can look at the front part of this, and I see that the front part is my perfect trinomial square. So I can go ahead and I can factor that perfect trinomial square. So I get x plus 7 squared. And remember, it's always b divided by 2 that goes in that back part of the brackets. And then I still have to multiply the negative 5 by the negative 49 because that was in my original set of brackets. So when I multiply that, I get positive 245. So that would be my, my vertex graphing form. Alright, next I'd like you to please give this one a try on your own. You can pause the video here, and then I will give you the solution as soon as you're all finished. So after you've given this a try, just take a second to take a look at the solution. Again, pause here if you need some time to go through this before continuing on. Alright, so here we go with one last example. Again, we're going to complete the square, and we want to determine the vertex, the max or min, from our new form. So first we have to, like before, we have to group the front part and factor out the a value. So y equals 5, x squared plus 6x, put in our plus blank, our minus blank, and then include our plus 41 at the end. Then in our blanks, we have to take our b value, so 6 divided by 2, and square it. So 6 divided by 2 squared is 9, and minus 9. From here, we look at just our perfect trinomial square, and we go through our factoring. So when we factor that, we end up with y equals 5, x plus 3 squared, and then remember we still have to apply that 5 to that negative 9. So we get negative 45 plus 41. So your final answer would be 5, x plus 3 squared minus 4. So if we take a look at this, we can see that our vertex, or our p and our q values, are negative 3 and negative 4. So my vertex is at negative 3 and negative 4, and the graph opens up because 5 is a positive value. So if it opens up, that means that it has a minimum value, or the vertex is a min. Now I'd like to remind you that there is another way you could have found the vertex instead of completing the square. So last section we learned about this little formula of negative b over 2a. So in this case, our b value is 30. So we'd go negative 30 over 2 times 5. So negative 30 over 10, which would give me an x coordinate of negative 3. So the x coordinate of my vertex is negative 3. Then we can find the y coordinate by plugging that negative 3 back into my original equation. So when you go ahead and you plug negative 3 in for all of your x's, you'd end up with a y value of negative 4 So my vertex is the exact same as it was before, -3 and -4. Either method gets you your vertex, but you are going to need to understand how to complete the square. So that's all we've got for today. So I'd like you then please for the rest of class to finish the assignment that's on the bottom of your notes page. We'll see you tomorrow.